Okay, this is going to be the A-star algorithm, and the reason I've got GeoGebra on the right hand side is what I need to be able to do is estimate the distance for various nodes from the point B. So as we go around, we'll be updating information, deciding which nodes we need, trying to find out where they are and what their current weighting is. So the weighting on this is actually different to what we've done before. We need two numbers. We need the cost of how much it is to get to a place, and also an estimate of what the cost is left to go to B. And what A star does is it says, what's the distance from B of a point? And so what A star does is it uses basically Pythagoras. So I'm going to calculate the cost to get to each point as I need to, and then I need to calculate the actual cost left for that point to get to the remote. The cost of how much it costs to get here and the estimate of how much is left, when you add those together, whichever one of those is the smaller will give me the next point to work for. So let's go through the first few nodes. A we've got to start at, and so we go to each point connected to it and say what's the cost to get there. So the cost to get to this one is 1, cost there is 1, the cost up here is 2, and the cost here is 3. Now to decide which node to go to next, I need to know how much does it cost to get to point B from there if I could fly directly. So if I go to this first one, that's at -9, 10, and if you do the values for it, it's the square root . So I've used GeoGebra. Remember, it's an estimate, so the integers is all that's needed. This is -9 and 10, and that gives me, is that point at 10? Yeah. And that gives me a total distance of 13.5. So the cost from here is 13.5. Look at the next one, that one up there. The difference is -712. So I'll check how far is that. And that one is 13.8 or 13.9. Go around to this top one over here, and that one is -10, -10 and 13. Which will give me a distance of 16.4. And this one over here is -1111. So that's going to be the square root of 242, which is 15.5, 15.6. So to choose the next node, what I have to do is I add pairs of these numbers together and choose the smallest. So this one's 14.5, that one is 16.6 in total. This one is 18.4 and that one's 16.4. So my next node is this one. The reason being the total cost of getting there and then the shortest distance to B means I don't need to come. That's my cheaper route. So now I calculate the cost to get to the next node that's connected to it. So the cost is 3. And I need to know how much does it cost to get from that node to B. That's -7 and 11. Remember, these are estimates. And this one is for 13.0. So 3 and 13.0 is 16, that one's 16.6, that one's 18.4, and this one is 16.9. So this is my next node to try now. That makes this value up to 4. That's not going to help me, so this value doesn't update. I don't need to say the cost is 4 to get here. So we now go through what's my next cheapest node. We've got 16.9. 18.4, and this one was 16.6. So I need to try this one next. Come round, this one is 3, and that one is 2. Remember, the cost is adding on those. Let's go to the slightly nearer one. That's minus 12.9. Which is almost exactly is 15. So that's 15.0. The cost to go from this node straight to B. Let's update that one. That position is 1212. So it's square root of 288, which is 16.9, and it's basically 17. Now, the reason I'm not actually writing down the total cost now is because this cost could get updated. This one won't. The one in brackets, that's fixed. That's how far is that point from there. So now I'm looking through. I've got 19, 18, 18.4, and now I'm at 16.9. So I update my path, which takes me to 10. And I want to know how far away is this from there. Well, that's 10 vertical, and it is only 10. Okay, so that's going to be a cost of 10. So I've got a total cost at the moment of 20. So total cost at the moment, that's 20 at the moment. And that one's been done. So we've just done that one. Look through 18.4, 19, 18.0. So we are going to have to do each of these nodes as we come round. This 18, this 3 here, this 18 is my next one. So let's go 18. Who's the next one? Yeah, the next one is that one. So this one updates to give us 4 on the outside here and 5 on the side here. Let's update the costs. And there's the mouse on this side. It's 12.8, which is 14.4. And the 5 coming this way. How much does that one cost? 10.8. And that's 12.8. So we've got additional calculations to be done, but we are not doing every single point. And we're fairly quickly going to get to processing this one again and find out where we get to a point where the value is to the final path is actually a lot better. So cost here, and where's my cheapest one? That's 17. That's 18.4. That's 17.8. That was 18.4. So 17.8 is my next best line. So we're now coming down to here to say 7. How much is that line? So 7 at that point is minus 11.7. Minus 11.7 is almost exactly 13. So that now is on equivalent footing to this one. And that's going to be a total of 20. So at the moment, I'm limited on that one. Only points left to process. This one is 19, beats that. 19 goes to here, which is 3, and then it goes nowhere. This has already been processed, so I don't need to worry about it. So those two have now been processed. That one, nowhere else. This one comes down. Yeah, this is a relatively cheap node. It's on a par with this one. So that one's been processed. I update it. This one is now going to be a cost of 6, which does improve my answer over here. So I do have an improvement happening. The cost there was 4 plus 2 gives me 6 and 13. So this is now 19. But we've got 18.4 up here. Move to the next one. That's 4. How far away is that point at the top? 9 and 14. And that gives me a cost of 16.6. And that is more expensive than coming down here. So that path's now been closed out to us for the moment. So we're now down to this one, which is 19. This point goes up, so that's 7. How far away is that point? It's minus 10 and 6. It's 11.6. If you remember when we did Dijkstra's, this path was actually, we came quite a long way down here before we got the sort of route. So we're probably going to come a long way down this way. I'm not expecting us to come around the top here at all anymore. So we're just comparing this path to coming this way. We've got 18.6, that's my cheapest so far. So 18.6, process that node, giving us 9 and 10. How expensive is it to get to the 9? How far from 9 back to B? It's minus 10 and 4. That's 10.8. And the 10 over here, which is that one, that's 8 and 5. And that's 9.4. Which one of these is cheaper? That one. So we've done the 7 there, we've done that one. So now we're doing 10, 19.4. It's cheaper than up there, so I've got to come this way to give me 12. That's going to be 13. It doesn't help, but it does mean we've already dealt with that position. There's nothing we can update. Sorry, before I do that position, let's tick it off in a minute. We'll just do the 12 here. That's 7 and 3. 7 and 3 is a 7.6. So that's 19. So I still can't actually get rid of this one. That's 19.8. I've got a 19.6, so I need to keep coming down this side. It's still my cheapest. So that takes me to 14 here. Which is 5 and 2. Yeah. And that gives me 5.4. So I'm still coming down this side. It's again 19.4. It's slightly better than that one. So we're now coming down to a 16. How much is it down there? That one, done that one, it's that one. 4-1. So I've done there, done there, done there. Oh, sorry, I should have gone back. Oh no, I did that one. I did the one before when we were doing that. So we're now down to 19.4. The 16 here is 4-1. The cost left is 4.1. And that 4.1 gives me a total greater than 20. We're now at 20.1. Here. So I know this one's going to come first. 19.8, that update will not make this one any better, so it's been completed. The reason I can only come back to this one now is it may have had other paths that I could have followed. We've got 20.6 at the top here. So that one's we're not going to get updated. So my cheapest one now is this 10 plus 10, which gives me an end of 20 with a distance of 0 left to go. Look around, I've got, and that's been done. Sorry, I need to also update this one. It's been 13. I need to check these ones. I need to check this one, which is go back, which is 14. And let's just check those and how far away are they. So 13 down there, that one is 27. And that's a 7.3. Again, greater than the 20, which my destination is, so that's not going to help me. And 14 over there is minus 3 and 13. And that's definitely going to take it over 6. 13.3, yeah, definitely not going to help us. So cost here is 27, cost up there is 20.6, cost here is 20.3, cost down here is 20.1. So my next node to process is 20 at the end, and that's my end. Now that's the cheapest node. I have found the shortest route. Now, the work that's been saved is, if you go back to Dijkstra's, that top side we went a long way round. We came quite a long way round here processing the work and almost got to the end here. But now with this one, we've come quite quickly down this side, and then we've got a few nodes we haven't done on this side. There's a lot of nodes up here that we haven't even had to consider, which has made it better for us. This one I could stop at 20 there, this one I could stop at 20 because my cost was now 20. Here, I've missed out all these extra bits. So that's the A-star algorithm. You do need a certain amount of accuracy to it, but it is about estimating and continuing until you know. If I wanted to be certain, I would update each of these next paths. So because I've been doing estimating, this one's an 8. And it goes to 18. So how far away are we on that one? 3 and 1. 9, 10, square root of 10 is over 3. That's 3.2. And that is clearly greater. That one's 20.3, and I've got a long distance to come. So this one's not, this is the one I'm worried because it's could get quite close. And we actually get to 20 here if we follow it through. No point coming around here, too many paths. This one updates to being, now we're at 0.69, and clearly it go up too far. So it's this estimate distance. If the next one is going to make it much worse, then that path can be closed off. So there's my speed up route. If it's done accurately, A-star will give you an optimum path. It's not uncommon though in computers and mathematics and graphs for us to say what's a good route, and this, using approximate distances, allows us to find a good solution which may not be optimal. If I did everything accurately, it would find the optimal solution, but doing everything accurately can lead to additional processing. Okay, so that's the A-star. Nice addition on top of Dijkstra.